Hey guys, today we'll be looking at section 5.5, which is called comparing linear and nonlinear functions. So we are familiar, very familiar with linear functions. Those are functions that we've looked at that are in the form y equals mx plus b. And remember, a linear function is something that's just a line on our graph. Now, nonlinear functions, as you could guess, are something that are not a line on a graph. And that's what we're going to, well, we're still on a graph, but it's not just a straight, normal line like we've seen so far. It's a little bit different than that. We have seen at least one type of nonlinear function so far. We looked at one of them yesterday, and you'll see that come up later in the lesson today, but I won't spoil the excitement. I'll wait till we get to that. Our learning target is that students will be able to identify linear and nonlinear functions from tables and from graphs. So a lot of what we're going to do today, you can kind of see right here with this table, but we're going to look at different tables, different graphs. You're going to decide, is this linear, is this not linear, and why? Why is it linear? Why is it not linear? So first, if we take a look at this table, and we are talking about if something is a perfect line and it fits in our form y equals mx plus b, or we're saying, hey, this is not linear, it would not fit in this form. Really what we're doing is looking at the slope, okay? If we look at first our x's, we see that from here to here, from 3 to 6, it's plus 3. From 6 to 9, plus 3, 9 to 12, plus 3. If we go from 40 to 32, we'd have minus 8, minus 8, and minus 8. So we can see that in our x values, we have a consistent change, and in our y values, we also have a consistent change. Remember, the definition of slope, or one of the ones that we talk about, is change in y over change in x. So if we did want to write an actual slope for this table, the change in y is negative 8 every time, and the change in x is 3. So we could come up with our slope. So this would be an example of a table that's a linear function, because all the x's are consistently going up by the same thing, all the y's are consistently going down by the same value. If we were to graph it, we would have a straight line. Now, a nonlinear function. Again, some type of function, some type of graph that does not have a consistent rate of change. So if we look at this table, from 1 to 3, we plus 2, 3 to 5, we plus 2, 5 to 7, we plus 2. So our x's are changing consistently. Our y's, plus 9, well, this is plus 22, and this is plus 50. So we don't have a consistent change in our y values. If we were to try to somehow write a slope for this, our change in y, well, first time it's plus 9, then, well, positive 9, then 27, then 50. I mean, I guess our x's stay the same, but we can't put all these together to come up with one slope that works every single time, so we can find every point on the line. Not with the linear functions that we've been talking about. So we would look at this table, and even though the x's have a constant change, the y's do not have a constant change. So this is a non-linear function. So that really is the most of the new learning that we're going to do today. Really, what I'm going to look at now is just a couple examples of what your homework questions will look like, and kind of give you a little bit of a head start on those. And then for your homework, you'll just be applying this idea, figuring out, is something linear or is it not linear? So first, if we look at this table over here on the left side, from 0 to 7, we have a change of 7, change of 7, change in 7. So far our x's are looking good. They have that constant change. Our y's, -5, -5, and -5. So just by looking at that, we can see that, yes, this is a linear function. That this is linear. Now, if we look over here at number 2, this is a graph that we are familiar with. We should see that this is the absolute value graph. Well, this isn't the parent function of it, but this is a form of an absolute value graph. And we can see this one is upside down because it's negative, but we can see that nice V for absolute value. I know all of you are saying that with me. But anyway, the question at hand, is it linear or is it non-linear? Well, this line on its own, if we cut it off right here, this line is linear, and this line is linear, but there's nothing that we can do to bring those together and make it one straight go-to line. So this is actually a non-linear function. If we were to have our table of values, we could not, if we were to have this set up in a table like here, we could not have a constant change like we did in this first one every single time. It would be different. It wouldn't be consistent. So it is non-linear. Another type of question you might see, which equation represents a nonlinear function? Well, remember, a nonlinear function is in our form y equals mx plus b. It might be something where b is 0, or we have that special case with a horizontal line. But if it's in any form than that, then it doesn't work. So let's take a look. Question A, y, part A, or option A, there we go. Y equals 4.7. Well, that's our special case where the y value just stays the same the entire time. And that is a linear function. That is, there we go, off our list. Let's look over here at B. Y equals pi times x. Well, remember, pi is just a number. So we could say y equals if we're rounding, 3.14 times x. Well, that works. That still would give us a consistent slope the whole time. Right here, y equals 4 times x minus 1. If we were to distribute this 4, we would just get y equals 4x minus 4. And that's a linear function. We could graph that right now. Now this last one, part C, it's kind of cut off. Y equals 4 divided by x. Y equals 4 divided by x. We do not have anything in our y equals mx plus b form, or any way that we could change this y over 4 over x to make it match our y equals mx plus b. And if you were seeing this on a homework problem and you couldn't figure out, you're like, oh, I just don't, whoops. There we go. I just don't know. And you say, I think it's this one, but I'm not really sure. What you can do is just make a little table. So if you put 0 in, you get 0 out. If you put 1 in, 4 divided by 1 is 4. If you put 2 in, 4 divided by 2 is 2. And already we can see that from here to here is 1, we're good. But in our y's, we go minus 4, and then here we go minus 2. Sorry, we go plus 4. From 0 to 4, we go plus 4, then we go minus 2. So we already have an inconsistency here in our y's, in the amount that our y's are changing. So all that to say that y equals 4 divided by x is non-linear. A couple other types of problems we'll see. Does the equation represent a linear or non-linear function? Number 4. Well, this looks like a linear function to me because it's right in our form. Y equals, our m value is 1, because they just don't write that 1 in, but mx plus b. If we look here at number 5, well, we have that divided by, again, we really don't have room for that, but let's see on our table. If we plug 0 in, 1 would give us 4/3, 2 would give us 8/3, 3 would give us 4 times 3 is 12, 12 divided by 3 is 4, and that's where I start to run into some trouble. As I start putting these points in, we have plugged x values into functions before and gotten our y values, so we're very capable of doing that. But we can see here is a difference of 4/3, here is a difference of 4/3, here's a difference of 2 2/3, so the inconsistency right here tells us right away, all right, no chance. No chance, not a linear function. It is non-linear. And this last one with number 6, and if for the explanation, if you had a table like this, that would be great. Number 6, we haven't talked about it a whole lot in this trimester, but when we see an x squared, that should trigger in our brain that we know that we're dealing with some type of parabola, like this. So if we see a parabola, or if we see a parabola in a graph, or if we see x squared in an equation, then we should see right away that that is non-linear. Remember, when we think linear, it needs to be y equals mx plus b. Our x cannot be x squared, x cubed, x to the 100th, whatever, none of that would work. And we can't be trying to divide by some slope or doing something goofy like that. It just won't work, and it will not give us a line. So our learning target today was students will be able to identify linear and nonlinear functions from tables and graphs. Well, we looked at a couple tables and we said, look, just look at the difference between each of these x values, look at the difference between each of these y values. If it's a consistent difference on both sides, then we have a, nice job, Layla, turned in that puzzle. If we have a consistent difference with our x's and our y's, then we're looking at a linear function, because that means it's keeping that straight line and we're doing okay there. If we see a inconsistency in the difference between our x's or the difference between our y's, then we know that something's going up. A straight line will it'll always be the same rise over run. Well, that doesn't show it very well. But if we have some type of weird curvy line, then it won't always be the same. You know, it might be super wide here, and then it gets really steep and steeper and steeper. So that change tells us that we're not dealing with a linear function. All right, that's all that we have for today. Like always, if you have any questions, make sure that you let me know. Otherwise, have a good weekend.